As a layperson, and I do a good impression of one because I am a layperson, I'm looking at saying, well, ChatGPT came out in 2022. At that point, there was a small cluster of GPUs in Virginia that they trained it on, and there was no, and there still isn't really any large GPU clusters run by Microsoft and OpenAI in Southeast Asia. But in Singapore, I can still open ChatGPT right now, ask it questions, get photos generated, that sort of stuff, and I don't need trillions of dollars worth of infrastructure built to do that. So this building is in anticipation of something. What's driving this huge boom if it's not an immediately monetizable product right now?
Consumer adoption, demand, wanting to not lose out on the next wave of innovation, which could take decades or could take years. So no one knows where this journey is going to lead. I'll draw the analogy with fiber. It played an incredibly useful role in society and getting broadband connectivity, but it wasn't necessarily a money-making business, at least in the early years. Same with AI. It's not clear what the monetization and return on investment is. And so there's hints that one hears from all these hyperscalers, these big internet and software companies on their quarterly investor calls are talking about increased engagement levels or better recommendation engines, and so they can charge more for some of their ad-based businesses. Or if you're running more of an enterprise AI model where you're charging for access for other businesses to access your tokens. So there's lots of ways in which these companies are getting paid, and there are companies that do talk about the revenue that they're generating, and it could be 40, 50 billion for some of the large foundation models, or it could be single-digit billions for companies that are operating AI alongside cloud. So it differs by company, but there's no kind of holistic view yet that we are definitively recovering our cost based on the revenues that we're seeing early in AI. But we're in the very early innings here.
Yeah, because I would sort of say to justify CapEx on new development, you want to be saying, well, if we don't spend this CapEx, we won't be able to sell a certain thing, which is either worth more than our current product, or it's a newer product that will generate new customers. And although there is an argument that reducing latency in Nano Banana might make more people use enterprise photo generation, that doesn't seem to fill the gap in CapEx that's being used to implement it locally. The one exception possibly is it seems that a lot of TikTok's business model is around channeling towards this, as you say, recommender and the ability to have their control over what adverts you see when you see them. And I read that they are predicting that almost 99% of advertising content will be either AI curated or AI generated in a quite short period of time. So they seem to have quite a clear business case on it.
Yeah, and Meta might be doing kind of similar. So that's more of a B2C or with the consumer in mind. That's kind of driving some of that attempt to monetize. And then there's more kind of pure enterprise. You can access my model to run your AI startup or whatnot. So a lot of things are being tried, but I think the jury is still out, and we're still in the very early innings to figure out what that return on investment is. Mm-hmm. But I think the attitude of these big companies is most of them have sufficient balance sheet capacity to continue to spend, and they don't want to miss out because we really are in a new era in terms of how you can use these things for your daily life and to run your businesses. And if you're not providing those tools, then you clearly are missing out versus your peers.
Yeah, Rhys has furiously been typing prompts into the various AI tools to come up with a name for this podcast, which we don't yet have, and it hasn't been successful yet. So that's an example of future value creation maybe versus what we've seen.
It had a few good suggestions. I won't say them now in case one of them is the name of the podcast, and then it becomes awkward when people make fun of it later. But yeah, it's had some good suggestions. I made a good picture of a data center value chain with only one spelling mistake, which was pretty impressive.
There we go.
We are meant to be talking about data centers, though, and this is probably a time for James to chime in. So when you've got these use cases that we're talking about, and as I say, at the moment, from my understanding, whether it's in China or in America, but the vast majority of your training and the use for these GPUs is happening in the United States still. And then if we're using these tools in Asia, at the moment, the inference is still, so there's a POP maybe somewhere in Singapore, but the inferencing is still being done probably on American GPU. What does the architecture for data centers look like? Why is it different? And maybe you can talk a bit about how that's changing site selection as well, because we're just having panels today at ITW, and yeah, they're talking about completely different data center plans, locations between inferencing and between training, and compare that to cloud as well.
I mean, so in the so pre-cloud, you would have what Bill Barney kind of coined the term storage operating centers, and that can be pretty much in the middle of nowhere. It's not latency sensitive. You want to go where the resources like land and power are cheap, and so you have examples of that in every region. It could be the Nordics, it can be Pacific Northwest in the U.S., or it can be in parts of Asia that are remote, like Inner Mongolia, would be an example, and that's where the content might reside, where you're basically just operating storage arrays. So that's been part of the architecture for a long time.
What sort of years? Like, this is pre-cloud, so this is early 2000s.
So prior to 2012, let's say.
And this is just companies storing reposits of photos or documents.
Emails and photos and things of that nature.
And what was the term?
Storage operating centers
I've never even heard the term.
Yeah. I mean, I don't know that it's a very prevalent term, but people might think of those as remote locations for data centers. But think of that as storage, right?
We're younger than
because it's infrequently accessed content. But if you have a database that needs to be pinged because you're running an e-commerce or financial trading engine off of it, then it has to be close to a major city. And if it's a consumer model, maybe like Netflix, where you need to serve content, then you need to kind of put some of this cache content at cable head ends or in telco central offices. So there's content that's going to be frequently accessed where latency matters, and that'll be closer to the CBD or closer to some of these suburban locations. And then the infrequently accessed content where you maybe need to update it once, at 2 a.m. or whatnot, will be in remote locations.
So at this time in history, then you've got your, call it an Equinix IBX or some sort of downtown carrier hotel.
Carrier hotel, exactly.
And then you've got the storage operations center out in the burbs. And then I presume we're moving towards the cloud era next with what you've described to me before, the availability zone architecture for each city. So how does that work?
Yeah, so cloud, Amazon was the pioneer, and then Microsoft followed, and then Oracle and Google as well, and then there's Asian versions of that as well. But the architecture is that a lot of businesses are running software that might have been written, in the 70s or earlier, and enterprise applications, whether it's new software or old software, it doesn't behave well if you have too much latency. If you're running like multiple branch offices of your corporation, and so cloud kind of needs to have a defined architecture, and every hyperscaler has their own sort of parameters as to how close the zones need to be, and how close each region has to be to a certain city. So 40 milliseconds or less. I think at one point IBM, that was kind of their parameter when they were running their cloud platform, and so you need to have AZs in essentially every time zone or close to each city, and so that's kind of this the intermediate between it. So that's not going to be a carrier hotel, because for cloud you need large contiguous blocks of land and power. So you're typically going to be in a suburban location.
So the reason then for the three buildings of rough site, what's the
so data centers that were architected at the beginning of this era were there was a premium on redundancy and having backup to your backup, and having gen sets that are generators that turn on and operate the site if the grid goes down. And a big part of the cost of a data center is the mechanical electrical plant to provide that uptime on those rare cases when the grid is not reliable. So the batteries and the generators are actually quite significant, even though they're almost never used. What the cloud companies sort of discovered is that we don't need to build or be in the most expensive data center. We can go to something that's a little bit lower quality, and then we'll make up for it with geographic redundancy. So if we go all in on a 100% uptime cluster, you never know when there might be some sort of a natural disaster or incident that would bring that site down. So they're going to put 2-3 of these things in kind of a triangle around each city. Amazon kind of pioneered that, and then other companies that developed that might have been using exactly those same employees that were doing it for Amazon. So you see these sort of
It
teams
does
of
look very similar, yes.
yeah. So journeymen that might have pioneered Amazon's AZ architecture might have then moved to another company, and so there's been a lot of knowledge transfer ever since the cloud era.
And this is where you have the birth of the likes of Digital Realty, sort of boxes of cheap power that are relatively downtown, but not in the center of town.
Yeah, suburban. And so data center build costs have actually gone down since, say, 2012 to 2020, partly because you just don't need as much backup because the customers, namely Amazon and Microsoft and Oracle and others, would rather have geographic diversity, and then they don't mind if there's an outage because then they've got these two others as backup.
Yeah, Microsoft claimed that if we were to be using the same workloads that we're using not on the cloud and they were all still on-prem, we'd be using, so it's 86% saving in terms of power and cost. So we'd be, what's that, 5-6 times more power cost usage to do it all on. Now, obviously, that's the cloud company saying that, so there's probably a vested interest in those calculations. But the costs do seem to have gone down with scale.
Well, yeah, I mean, cloud data centers are operating at 80% or higher utilization, and enterprise data centers, those that are like owned by banks, might be like 40%. So you definitely do get a benefit from having a pooled set of resources with higher utilization.
And this is kind of when I got into the industry. James is a little bit more experienced than I am, but I came in as it was becoming the sort of the race to the west, the gold rush in Asia of AZ deployment. So it seemed like every week a hyperscaler was announcing a new AZ in a different Southeast Asian or North Asian country. There's 3 now in different parts of Japan, China, etc. And I guess the business case then sounds like, so if you've got 3 20 megawatt data centers to make your AZ, which is going to cost you, say, $600 million of CapEx, to $200 million a pop, then you need to be making you need to be looking at that as your return on investment case for your cloud sales in that country to justify bringing Azure or AWS or Google Cloud to that particular country. Okay, so that was the market at the time. How do we now get on to AI, where the numbers have shot through the roof and the site selection process is evolving again?
So first of all, cloud is still a very profitable business. You saw revenue growth just this past quarter for most companies well north of 20%. And Amazon is the largest cloud company, and I think they may have only grown 17%.
They were devastated. Only 17% growth.
Yeah.
$100 billion business.
But off of a huge base. So it clearly is a proven product, and there's still amazing amounts of IT that happen in the corporate environment that have yet to go to the cloud. So there's still a lot of growth left in that category. With AI, you can't, we might be many years away from being able to kind of declare victory that AI saw a massive return on investment. As I mentioned earlier, the jury is still out.